Good morning, student. I, Dr. Paresh Kulkarni, welcomes you all on my YouTube channel called Engineering Chronicles: A Need for an Engineer. We are in the lecture series of machining time calculation for a variety of operations, in which we already have seen machining time calculation for turning operations. Now, today we are going to see how to look into machining time calculation for drilling operation. But before looking into that part, let's quickly discuss why it is important for any manufacturing unit to know the machining time calculation, do certain analysis on machining time calculation, because ultimate objective of any manufacturing unit is what? To achieve certain required productivity and eventually to satisfy the customer, right? But do you really think to achieve the required productivity or to satisfy the customer is possible without having the proper production capacity planning? Do you really think without doing the proper cost estimation we can achieve that? Certainly not. So this machining time calculation will help to achieve certain small objectives to reach eventually to the larger objectives. Now when we think about the machining time calculation, it has certain elements like setup time, machining time, operator time, but these times can vary from operator to operator, may vary from machine to machine, but one of the key element of machining time calculation, that is cutting time, that will vary on certain other factors like cutting conditions, metal removal rate required, targeted MRR, and so on. So that is what the key or the major contributor in terms of machining time calculation, because based on the geometry which we have, size of the component, geometry of a component, that will vary the eventually the cutting time, and hence the cutting time calculation is very much necessary. Now let's see how to look into the cutting time calculation going ahead, right? So this machining time calculation will help you to have the efficient production planning. It will help you to have the efficient capacity utilization. For example, XYZ machine is taking undue additional time due to some reasons and which we are unable to identify. Eventually what will happen, that decided time, within decided time we may not be achieve our target, because at XYZ machine due to certain condition additional time was put on by the operator, and eventually we lack of reaching to the end target, right? Sometimes cost estimation, one of the machine is taking additional time, which are various cost factors are associated with that, again we will not reach to the target. Sometimes bottleneck identification is very much necessary, because of certain conditions additional machining time is taken by some people, some operator, or by some machine, and due to which at some place we see the bottleneck. So for identification of that we should know how to do the machining time calculation, right? For various operations the standardization is necessary, that specific operation should be completed within specific time only, and to decide that, to do this time standardization, we should know how to look into the machining time calculation for specific operation. If we don't do that, definitely we won't be able to standardize the time required for particular operation, right? So eventually what I'm trying to tell you here, for any manufacturing unit to reach the desired productivity level, to reach the desired customer satisfaction, everybody should know how to look into the machining time calculation. What are the various factors which contributes to have the certain machining time calculation? Obviously, to have the higher productivity, it is always expected that machining time to complete the given part should be as minimum as possible. So this is how the machining time calculation is important. Now we are, as we already have seen machining time calculation for turning operation. For the video which we have already gone through, link of the same I'll give in the description box, you can just go through it once again. So now let's see how to see the machining time calculation for drilling operation. Why? Because from turning to drilling, what has been changed? Mainly the cutting tool, mainly the way we operate the cutting action. Based on the cutting tool, cutting action, what has changed from previous operation to this operation, let's see much in detail. right? So let's go to that particular part. Good morning, student. As we have just seen the importance of machining time calculation for any manufacturing unit, that is why it is important. Now let's see the machining time calculation for certain next operation called drilling operation. So welcome once again to my channel called Engineering Chronicles. Now let's see the machining time calculation for drilling operation, right? There is a generic formula to get the machining time calculation as the length of tool travel upon feed rate. The same formula we had for the turning operation as well, right? What is most important here? The total tool travel length. We had some different considerations in turning operations. Now we have certain different consideration in drilling operations. Now let's see how to calculate the total tool travel length. Suppose we have one plate of a certain thickness over which we have to do a through drill operation. Now let's see how the total length can be calculated. So when we think about the total length, that is the length of tool travel, it includes four different lengths. First, obviously, the thickness of plate L1, right? Length 2 is approach length. Tool has to travel certain distance and then touch the workpiece, because tool can never be always in touch with the workpiece. It is at far distance. That distance is nothing but L2, approach length. Third is cone height. Now here tool has just touched the workpiece. Tool has not acquired the entire diameter onto the workpiece, right? So tool has to travel distance equal to L3 called cone height, as we see here. Then it has acquired the entire diameter onto the workpiece. And last length is L4, over travel of a tool. Tool will not stop at the last point. It will have little over travel. So all these four length we have to consider to get the total tool travel length. Now here the length L2 and L4 can be assumed at some specific length, because that distance may vary from operator to operator. So by and large, we have to assume something, maybe 6 mm plus 6 mm, 12 mm, 10 mm, 15 mm, because that may vary from 1 to 1, right? So this L2 and L4, generally called approach distance and over travel, we'll assume equal to 8 to 10 mm, right? So we are done with this L2 and L4. L3 was simply the thickness of workpiece. We know that we have to add. What we have to calculate very meticulously, the distance L3, cone height, that will vary from one tool to another tool, because as the diameter of the drilling tool changes, this L3 distance will change, and we have to calculate very meticulously, right? Now let's see how it can be calculated, right? Then once we will see a little later, once we have this total tool travel, then we have to know what is the feed and what is the speed, that is in RPM. That also we will see how to calculate, right? And once we have L, F and N, the total machining time calculation can be calculated very easily. Now let's see how we can look into calculation of L3 distance, that is cone height. As we can see here, as diameter is changing, we have just taken this conical part over here for understanding. What is phi? Drill bit diameter, diameter of the drilling tool. Every drill tool has specific point angle, as you can see over here as well. As we are moving from one tool to another tool, maybe from carbide to steel, steel to carbide, and so on, the point angle is standard. It will vary from 118 to 125 to 132 based on the material of a tool. We can see this is point angle, right? It may be 118, maybe 130, maybe 135. Tool, we are going to select the tool, so we know the drill diameter and what is the point angle of a selected tool, which is written on the toolbox itself. So we know that angle. So we know this phi, sorry, theta. We know this phi as well. As we know this diameter, angle, this vertical height L3 can be easily calculated. Let's see how. Point angle we know, maybe based on our selection. Can see here, what is that? This is drill diameter d by 2, phi by 2. So this d is known to us, this theta is known to us, this L3 or h easily can be calculated by this equation. So d is known, phi is known, we can calculate h. H is nothing but this L3. So we have now all the four lengths which we can add, and we will get to know the length of tool travel, right? Understood? Feed is directly given. We know speed, if not given, we can calculate. How we will see? Sometimes you may be directly knowing, no, you know directly what is n. So L is known, F is known, n is known, Tm, that is time, can be calculated. Now let's see, for example, right? Now let's see on next. Now let's see as an example how to look into the time calculation for drilling. Now we have these certain conditions like, let me read. As shown in the figure, calculate the drilling time required for drilling two holes of a 525 mm diameter to the length 150 mm, that is first hole. Second hole of a 15 mm diameter to the length 120 mm. Certain cutting conditions are given like cutting speed, feed, and point angle is given here. Because tool we have selected, so we know the point angle of a particular drill tool. This is what the condition, right? Now what we have here, this is hole number 1 of a diameter 25 over the length 150. Whereas second hole is diameter 15 over a length 125. Both are little different. Let's see how. So this is what the equation we have. The time calculation, total tool travel length upon feed rate. Let's see how to calculate the L1, L2, L3, L4. Now let's see for hole number 1. For what is L1? Through hole, thickness of plate 150 mm. L2 and L4, approach length and over travel of a tool, we can assume somewhere around 10 to 12 mm. L3, point angle, sorry, cone height. L3 cone height we have to calculate. L3. Now let's see how. We have just discussed how to get that cone height. Now let's see what we know. The diameter of the drill is how much? 25. So this is 25 by 2. Point angle is 118. So this is 118 by 2. H or L3 can easily be calculated by this. If we just go ahead to calculate, we'll get the H cone height, that is L3. Once we have this, we can easily calculate now we get here the total tool travel length 169.51 mm. Now we have the equation. What is left now? The feed is given 0.5. Good. N is not given. That is RPM, speed is not given. How it can be calculated? We have the equation. Cutting speed, but what is provided? The cutting speed. What is the formula for cutting speed? Pi dn by 1000. This 25 is a drill diameter. What we have? Drill diameter is 25. Cutting speed is 25 meter per minute. Pi. So we can easily calculate now the speed n 318.30 rpm. Now everything is done. So we can calculate now the time required for hole number 1. All right. So now we are done with the hole number 1. Now let's see for the hole number 2 as well. For hole number 2 here. This is hole number 2, right? Let's see what will change here. We know the formula. Total tool travel length upon feed rate L1. Okay. What is written here? L1 is what? The second hole is not through hole, right? So let's see the depth of drill is 125. So L1 will be 125. What is L2? Approach length we assume equal to 6 mm. Do we really have to assume this 6 mm, which is over travel of a tool, which was in the case of a through hole, right? But here, do we have the through hole? No. So there is no chance that tool have some over travel. Tool will have a specific travel. So in the whole number 2, we should not consider this L4 or over travel of a tool. But even if you consider, it will not make that much difference as such, right? But ideally, principally, we should not consider this 6 mm. But for the sake, I have considered here the L4 distance as well. Let's see, calculate the L3 now. L3 will change from hole number 1 to hole number 2. Why? Because drill diameter has changed. Here drill diameter was 25, whereas here it is 15. So as the diameter is changing, cone height will change. Why? Because initially it was 25, now it is 15. Point angle is same as per the given conditions. Now, what we have, d by 2 tan theta by 2, just go on calculating, we'll get the h, cone height. Once we have the h, we can easily now have the total length L, total tool travel length. As I just said earlier, this 6 mm principally should not be considered, but just for understanding the difference, I have added here. Okay? Now let's go ahead. As we have the L, the way we did it in the previous case, we have the formula. Total length is 141.5. Feed we have that is 0.5, and we have to calculate by dn by 1000. So from this we get the n is 530.51 rpm. Now everything is there with us. We can calculate the total time required for hole number 2 is 0.5 minute, or maybe in terms of second. Understood? I hope you have understood now how to look into the time calculation for drilling operation based on a certain given cutting conditions, right? So I think let's stop. But the most important, if you have liked the video, if the concept is very much clear for you, what is the next? You should you should hit the like button, share as much as you can, and subscribe. So please do subscribe. We'll meet in the next chapter, something maybe machining time calculation for milling operation. That is a little complicated than previous two, right? So I think let's stop now. We'll meet in the next video. Until then, take care. Thank you.
वीडियोस बनाने हैं, फिल्मोरा है ना।